All right, today we are diving into a piece of tech called TurboQuant. And believe me, this could completely change how fast and even where you can get a life-saving medical diagnosis. It's a fascinating solution to one of the biggest problems in modern medicine, and it all really starts with one big question.
Yeah, think about it. Why is the most powerful, cutting-edge medical AI pretty much a luxury item, locked away inside the wealthiest hospitals? The answer isn't just about cash. It's about data and a huge computational problem that's creating a really dangerous divide in healthcare.
And what this creates is a growing ethical gap in care. So on one side, you've got these massive urban medical centers. They've got the expensive servers, the power to run these giant AI models in an instant. But on the other side, you've got smaller, rural clinics with way less computing power. And that means long waits and just unequal access to the best technology out there.
So what's at the heart of this whole problem? Well, it's the absolutely massive size of the data. A single high-resolution 3D medical scan can be more than 100 gigabytes. Now imagine trying to push that through a gigantic AI model. It creates this huge computational bottleneck, basically a data traffic jam that smaller clinics just can't get through.
And look, this isn't just some abstract tech problem, right? This has a very real, very human cost. We're talking about diagnoses that get delayed, which can change outcomes. We're talking unequal access to technology that could save a life. Not to mention all the fear and privacy concerns that pop up when a system isn't fair or available to everyone. But what if? What if you could shrink the AI model instead of trying to shrink the scan? Well, back in March of 2026, researchers from Google introduced a breakthrough that does exactly that, and they called it TurboQuant.
Okay, so the first thing TurboQuant does, and this is a huge deal, is compression. It can take these enormous AI models and shrink them down, making them 6 times smaller. And get this, it does it all without needing to be retrained from scratch, which saves a ton of time and resources.
And when you make the model that much smaller, you get an incredible side effect: speed. This compression leads to a truly staggering 8-fold increase in how fast these diagnostic scans can be processed. For a doctor's workflow, that's an absolute game changer. To really get why this is such a big deal, you have to understand just how quickly this problem popped up. It was only 2022 when these big AI models started showing promise in healthcare. But by 2024, they were already so big that they created what people were calling a memory crisis. That urgency, that real clinical need, is what pushed the development of TurboQuant. Okay, so it's smaller, it's way faster. But is it safe? Because let's be honest, in medicine, speed is totally useless if it's not accurate. So the absolute most critical question is, how does TurboQuant shrink these models without messing up the results that doctors and patients are depending on?
I mean, this is the first thing that comes to mind, right? If you compress anything, a photo, a song, anything, you naturally worry that you're losing some of the important details. In medical imaging, losing one tiny critical detail could be the difference between getting a diagnosis right or getting it wrong.
So here's a look at how it actually works. It all starts with that massive scan. Then, it uses this clever technique called 3-bit quantization to shrink the AI model down. But the real secret sauce, the most important part, is step 3, residual error correction. This is the built-in safety check that makes sure everything stays accurate. Now, that error correction is based on a mathematical technique with a mouthful of a name: quantized Johnson-Lindenstrass, or QJL. But you don't need to be a math genius to get it. Just think of it like a tiny 1-bit safety net. It runs right alongside the main process, and its only job is to constantly double-check that the compression hasn't accidentally wiped out any critical medical details. I absolutely love this analogy from the source material because it's just perfect. It's exactly the right way to think about it. The whole goal is to pack everything into a smaller space, to be way more efficient. But your number one absolute top priority is to make sure that the most important, most delicate instruments don't get crushed in the process. So really, the whole system, especially that QJL safety net, is built from the ground up to prevent those sneaky, hidden errors and biases that can creep into other compression methods. It's that relentless focus on accuracy that actually makes this a viable tool for doctors to use in a real clinic. So we've got a faster, smaller, and safer AI. What does that actually mean for the future? Well, it holds some incredible promise for making diagnostics available to everyone, but it also means we have to be pretty careful. As one leading radiologist put it, the impact here is just profound. When you can take the time it takes to get a result from hours, maybe even days, down to just a few minutes, you're not just making things a little more efficient. You are fundamentally changing the patient's entire experience and maybe even their outcome.
And that's what brings us right back to that ethical gap we talked about at the beginning. A bioethicist reminds us that the real way to measure if a technology like this is successful isn't just how well it performs in a fancy, top-tier hospital. It's whether it can actually bridge that gap and lift up care for everyone, everywhere.
So it's really important we look at this with a balanced view. The promise is crystal clear, giving rural clinics access to advanced AI, radically faster turnaround times, and much lower hardware costs. But the precautions are just as critical. This tech needs to be rigorously tested in long-term clinical trials, and we need careful ethical oversight to make sure it's rolled out safely and correctly. And the potential scale here is just massive. I mean, sure, the big urban hospitals will benefit, but look at this. The vast majority of the impact, a whopping 80% combined, could be felt in the rural and community clinics and the global health initiatives that need this technology the most. This is squarely aimed at helping the underserved. So I want to leave you with this final thought. TurboQuant proves that we can make medical AI dramatically faster and more accessible. But the bigger challenge is still out there. As we keep accelerating these incredibly powerful tools, how do we make sure we're also building in the safeguards, the ethics, and the wisdom to ensure they truly serve all of humanity?